All right, good morning. Here is today's lesson. So get ready for some notes. I'm sorry I couldn't be in class with you guys today, but I am doing some other things. So hopefully this will help without me being there. All right, so here's our EQ. How are data points and scatter plots used to make predictions about real world events? So we are working through our statistics unit, and specifically, we're going to be looking at lines of best fit. So get out your notes, get ready. What is an independent variable? So to define an independent variable, in this slideshow, which is available, you have access to this in Google Classroom, you can click on the word independent variable and it'll bring up the definition in Discovery Ed. But basically, think about the independent variable as something like the cause of something. It is what it is, and it could be like something like time and age. Those things seconds are seconds, minutes are minutes. Your age is your age. So it's independent. Nothing, it just stands alone. But what it does is it can impact the dependent variable. So what is a dependent variable? Again, you can click on that in the slideshow. But the dependent variable is the effect. So in other words, the independent variable affects change in the dependent variable. So we'll see lots of examples of this as we explore independent and dependent variables and how they relate to scatter plots. So what is an association or correlation? So let's look at this data here. The number of text messages per day, and if you look down here at the bottom along the x-axis, you'll see it shows age, and then it shows text messages per day. And I want you to pause right here and notice some things about it. So what do you notice? If you look, we can see that there are a lot of points, there are lines. We can kind of see as the age goes up, so as our age increases, it looks like the text messages per day decreases. So let's look at this here. Here's our independent variable, the age. You are the age that you are. And the dependent variable is the text messages. So what do I mean by that? So y, the y-axis right here, relates to this, the number of text messages per day, whereas the x-axis is my independent, and it's going to usually be that way. So let's look at this specifically. Let's take a look. If I am 24 years old, let's look at that guy right there. 24 years old. So they interviewed a bunch of people. Some of them closer to 12 years old, some as old as 72. Let's look at this 24-year-old. So how many text messages about does that 24-year-old claim to do in a day? And looking at that, it's just under 25. So it looks like about 24 text messages per day. All right. Well, how does that compare to our 72-year-old? And I'm going to write this in point form. So 72 is my x. And if we look back, it looks like, if that's 5, it looks like maybe four text messages. All right, so a 72-year-old texts 4 times a day on average. And then if we ask someone who's 12, well, you can see that there are, and I'm going to go ahead and erase that a little bit. You can see that there are 2 12-year-olds that were asked this question, this 12-year-old and this 12-year-old. This 12-year-old says they text just under 30 times, about 29 times. Whereas this 12-year-old texts about just under 25, so maybe 24. All right, so there's some data. So what do we notice? What kind of general trend could you say is happening here? And hopefully you're noticing that the trend seems to be downward. In other words, as X increases, Y, the independent or the dependent, decreases. So we call this relationship between age, here in this case, and text messages, the relationship between the X and the Y. We're going to call that a correlation. You also might hear me say association. And they mean the same thing. It's the degree of relationship between two variables or data sets. So, in other words, how much, like the degree is like how much of a relationship exists between two different things. In this case, age and the text messages. And this relationship is the older you get, the less you text. That's kind of summarizes that in a nutshell. All right, well, let's keep looking. Here's another one. Let's look at the correlation between babysitting time and the amount of money earned. So we have our independent variable, our X is how much time we spend babysitting. Maybe I feel like babysitting 2 hours, maybe I feel like babysitting 8 hours. That is what it is. How much I get paid, though, depends on how many hours I decide to babysit, which is why the amount earned is the dependent. It depends. How much I earn depends on how many hours I babysit. And so if we look at this overall trend, you can see that the more time I spend babysitting, the more money I make. Although I got to tell you, these rates are not that great. So, like 4 hours of babysitting, it's going to get me $7. Yeeks. So 4 hours is $7. In other words, 4 comma 7. Well, I might see this one $4 or 4 hours only earned me $4 there. So you can see, like, these are different people surveyed, or different kids will say surveyed who babysit. And this is what they found, that the more time you spent babysitting, the more money you earned. Now, something can be said though about let's talk about that guy right there. That's 4 hours earned $12. So this 4 hours earned $12 compared to this one that only earned 7, and this one which only earned 4. So we call this guy, it's way out there. We call it an outlier. It kind of doesn't follow the general trend, and you could maybe argue that this one doesn't either. This one also might be an outlier. 6 hours, $5. It's kind of not really close to where the rest of these guys are. So that might be another outlier. All right. So moving on, you notice that in those scatter plots, I had that line that ran through it. And so what is a line of best fit? Now we're getting to kind of the heart of this lesson. So here's a scatter plot. There's your scatter plot. And on it, you can see all these different points. I don't know what my X is and I don't know my Y. I just know their numbers. I don't know what this represents. But each one of these is somebody's input or something's input. So we have all these things. So now I kind of notice that I sort of see there's sort of like this overall space that they kind of exist in. And it looks like it's coming from high down to low. We will talk more about that. But what would help me maybe better look at this data is to have a line that kind of tries to capture as many of those points as it can. And this is called our line of best fit. And a line of best fit, if it's done right, you're going to have as many points on that line as you can while still having about the same number that don't fit on the line as you do above the line. or below it, so that you want about the same number that are above and below. I think this could be, we could have a better line of best fit, but this is not too bad. Here's another example. Here you can see the points are a little bit farther away from each other. Here they were closer in to one another. Here they're a little bit more spread out, but I think we can still draw a line that kind of captures a lot of points. We've kind of got one, two, sort of three, four, five. Five of the points are on, and we have hopefully about the same number on above it and below it. So 1, 2, 4, 5, 6. 1, 2, 3, 4, 5. So we have 6 and 5, but that's really close. So this is probably a close line. It's pretty close to the line of best fit. And that's really all we're doing with a line of best fit. It's trying to capture those points, as many of them as we can, to represent the trend of the data. So it's just a straight line that represents the trend of the data on a scatter plot. So is it going up? Is it going down? What are these points? What's the relationship like? And does this line kind of capture that? All right. So we're going to see those lines of best fit and how they help us kind of look at scatter plot data. So here we have an x-axis, y-axis, and we have these dots, and you can see they're about the same number above and below it. And while we only captured one of the points, that's okay because we have about the same number on either the one side or the other side of the line. So this is a line of best fit here. And if you notice the direction that the line is heading, call that a positive relationship, a positive correlation, positive association. You'll hear those different words describing the same thing. And if you notice, it's going, like I said, up. So as X values increase, so do the Y values. And you might know that as a positive slope. We've done this. So hopefully you remember that this is a positive slope. So my next question is, what is a negative association? What would your prediction be for what that graph might look like? Hopefully you're kind of thinking something maybe along this line. It's heading down. It's heading negatively down. So as we increase along the x-axis, my y values are decreasing. And that is our negative slope. So positive correlation, in a positive correlation, it's going up. In a negative correlation, it's going down. What other kind of relationship things should we be looking for? Well, how about strong correlations or associations? So here we've got a point, or I mean a scatter plot with a lot of points on it. And if you look, these points are all really, 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 really close to each other. And if I draw my line of best fit, you can see none of these points are very far off of it and about the same number above and below. Maybe this could have been slid down a little bit, I think. But there you have it. Now let's compare that to this one. Notice how the points are much farther apart from each other. So it becomes just a little bit harder to decide where to put that line of best fit, just eyeballing it. But there it is. So what we have is our strong and weak. So this is a strong correlation, and this is a weak one. And specifically, these are both heading up, so they're both of them are both are positive correlations. So we would say this one here is a strong positive correlation. And we would say, actually, I should do that. Sorry about that. This is a strong positive. Correlation. This one is also positive, but it's weak. So in other words, whatever these points are, this tells me that these two things, whatever my x is here, whatever my y is here, they are strongly, their relationship is very strong. That for sure, as x goes, I can expect y to go up as well. So as x increases, y increases, and it's really tightly connected. Here, yeah, as we go along the x, as x increases, yes, y increases, but there's a lot more variation. It isn't so tight in. So something you might notice here then is that the points are close to the line in a strong association, but they're farther away from the line in a weak association. And again, these both happen to be positive, but you can have this with negative. So let's take a look at this. We have 8 different scatter plots, and I want you to pause and take a look at those. And then I'm going to have a series of questions for you in the Edpuzzle, but let's start with this one. Which scatter plot shows a positive association or correlation? So I think positive, you're looking for something that goes from low to high. So I think you could make an argument for sure about D. D is definitely positive. If I were to draw my line of best fit, go like that about. So this is definitely positive. And I think you could argue, yeah, this one is positive. And then you could, I think, argue that this one is positive. It's a little harder to tell. Like, I'm not convinced that is the line of best fit. So I'm going to try it again. So I'm eyeballing these lines of best fit. There is a way to mathematically figure it out. So I think you could argue that this one is positive. We'll come back to A in just a second, because I'm not entirely sure we could argue that this is positive. I don't know. These are really spread out. I sort of see what feels like a trend here, but it's a pretty big, wide thing. So I'm not totally sure. Let's come back to that one. How about which ones are now? Let's look at weak associations. So which ones do you think show weak? In other words, they're spread out and not great about forming a tight line. So right away, I think we can say safely we can eliminate both D and H. Definitely, these are not what I would call weak. I would probably say C, that's pretty tight, so I probably would not include that. You could potentially make an argument that G might be sort of weak, although I think I do see like a pretty good trend down, but they're starting to get a little. You could argue one way or the other. I'm leaning that this is not weak, but then we start to get here and here, and oh my gosh, over here. So these, I think we could argue that this is weak because it's not as easy to draw a line of best fit and feel confident that you're catching as many of the points as you can. And F is also kind of hard, like sort of hard. I think I'd argue that these two are definitely weak. If you said A and E, I think you could make an argument for those, but there's also something called no association or no correlation. And those are ones where they don't really have much of a relationship. Whatever's happening with X has no bearing on what happens with Y. And so you'll find that those points are just completely scattered. They don't follow a trend. Like if you try to imagine drawing a line on this one, I don't know, you could argue that that's the line of best fit. You could argue, well, maybe the line goes like that. Or, maybe it goes like that. But it's really hard to tell. So I would say for sure E is no relationship. No correlation. And A could either be weak or um, or maybe even no correlation. Some other questions like, do we know which ones show a negative association? So negative is that downward. For sure is H. For sure is G. And pretty sure F. E's probably not. So those are probably your negative associations. What about strong correlations or associations? Which ones have strong ones? Yeah, if you said D or H, these are as strong as it gets. I mean, these virtually form their own line. That's a little off, obviously. But these form their own line just about. They're that strongly associated, like so strongly associated. So this would be, again, a strong positive and then a strong negative. And again, you could probably put an argument for these both being strong, and I would accept that. I would say, yeah, sure. I think C and G could be argued as being strong. Right. So let's put this all together. We're going to go to Discovery Education. To do that, you're going to be going to 10.2 Investigation 2. And I will make sure to put this link or this information in Edpuzzle and in Google Classroom, but you can click on this link here. Oh, sorry, let me reset that. So questions you're going to ask are, what are dependent and independent variables, and what kind of associations do you notice? So you're going to click there on this link in the slideshow. So you can find this link either one here in the slideshow or two in Google Classroom under the stream. And if I can put it in Edpuzzle, I don't know yet if I can do that, but maybe Edpuzzle. I'm not sure, but for sure you can find it here on the slideshow and in Google Classroom under the stream. So once you're there, let's go ahead and get there. So this is what it looks like. You're going to get to this interactive. And again, we're right here. If you're just going straight into Discovery Ed, it's 10.2, 8th grade. So 8th grade. 10.2 Investigation 2. That's where we're at. So which is the line of best fit? So let's go. So we're going to go into this, and I want you to see the first part of this. It's going to be an interactive. We could even recreate some of those scatter plots that we saw, but we're not going to do that. We're just going to play. And you'll notice as I add points, as I add scattered plot data, you're going to see that this little association meter shows me that this is both positive and negative, or positive and strong in terms of its association. But if I were to start putting different spots here and here and here and here and here, it starts to become very weak and have no association whatsoever. So reset that. I can do down, and you're going to see the closer these are, this is very strong, strong negative association. You're going to even notice here there's a line, an equation for the line itself. If you remember, we had this is my slope. Notice it's negative, right? That's what that negative tells me. And then my start value is where it started right there, which is 22.61. Just out of interest, we did lots of work on linear equations, and this is evidence of what this linear equation is for this line of best fit. So let's hit continue. And now you're going to see we have all these different data sets that we can look at. And these data sets are going to help you. Let me get out of teacher view. Sorry about that. Oh, no. Are going to help you answer these questions down here. So world record times for the mile run, distance traveled versus cost of airfare, and so forth. So you're going to find those data sets here. And so this will be the first one, but you can look at any of these. So let's look at global sea level changes. So the year is our X, which means it's our independent variable. And then the level that the sea is changing by is in inches. So they're measuring the sea level changes. And then you might notice you see a trend going up. So then you're going to take the line creator here, and you're going to see if you can create a line of best fit just by kind of eyeballing it. Remember, we want to try to capture the data as best we can, the trend of the data. So we want kind of the same number above and below the line, and we want to make sure we capture as many points on the line if we can. So we have 1, 2, 3, 4, 5 above, 1, 2, 3. So I feel like I need to bring this up just a tiny bit. So let's check. How close did I get? I got a best fit line. So yay, pretty cool. That doesn't usually always happen on the first try. So now that I've done that and I've kind of looked at this, I can begin to think about some of the questions about the global sea level change. So if I come down here, I can find that. So what's my independent and dependent variable? I'm going to answer those questions here, or you are. And then you're going to describe what kind of association you see. So if we go to the sea level change, what kind of association do we see here? Well, I can tell it's definitely positive because it's going up. It's like going uphill. And then it's pretty tight in. So these points, I would say it's a strong positive correlation. That's what I would write for my answer here. And then you're going to think about, well, what does that tell me? Why did I give it that? Why did I give it that in that reasons why? Tell me more about that. So then once you're done, make sure you hit the submit button right there so I can see that you did it and I can check your answers. And then you're going to keep going. Some of these you can skip. So you can look at an association here and answer those questions. And then again, hit submit. And then you can skip how to best fit a line. You can skip that. You can skip the same but different. But I'd really like you to think about stories told. So I'd like you to talk about relationship between two variables when it comes to larger homes costing more or not. So you're going to see this right here. This right here. So this is the one I want you to look at this. It even provides you the table of the data. And then what do you notice with the trend? right there. And I don't think it's going to let you hear. You have to go back to the interactive and answer that there. But what do you notice when you create your line of best fit? What does that tell you about this story? Like, what observations could you make from this? How could you use this to predict what a home would cost based on its size? And could you estimate the cost of a house that is 1,200 square feet? And how does the data table help you analyze that? And then again, you're going to hit submit. And then when you come down here, predicting size and cost and match the equation, I don't want you to worry about that unless you'd like to give yourself that challenge. But I'm not going to worry about that. I think anything out after this is all going to be just things that you can do if you want to challenge yourself. But for now, just make sure you look at the data about the house and answer stories told. And then, of course, all this information up here about the different variables, their associations, and why. All right. And that will be your Discovery Ed work. So from there, don't forget, after you're done, you're going to have a new asynchronous. It is your last asynchronous assignment, and it is in Class Kick. It's called Scatter Plots and Two-Way Frequency Tables. So go ahead and make sure you do that. That'll be due next week. We'll kind of talk about it. And then finally, the iReady diagnostic. Again, remember, if you are not satisfied with your MyPath grades for your previous iReady work, like maybe you didn't practice, you didn't do those lessons, doing the diagnostic will give you a 4 to replace one of those previous grades. So I would encourage you to do the iReady diagnostic if you're not happy with your MyPath grades. And that's it. So I hope that you have a great day. If you have any questions, please make sure you reach out to me. I would love to help you. Thank you so much. I appreciate you guys.